Thank you very much, Sony Pictures and Sony Professional, for hosting in the DPC Center of Technology, showing the greatest Sony has. Tonight, we're going to do a couple things. Part 2 of the equation is a panel. HDR, 4K, we have an incredible group here talking about that. But before that, we got to do a little bit of transactional business. And Keycode Media is all about keeping you ahead of technology. And today we have our good friends from StorageDNA, who we saw many, many years ago as leaders in thought of how to handle metadata, media, and the issues within production and post-production. StorageDNA had the opportunity to glimpse the ODA technology. And they worked with Sony and worked through the API to come up with a revolutionary entrance into the market that can change how everybody does post-production today. So I think you're going to find a very exciting and compelling story. And by the way, you are the first to hear it live in Hollywood. So I'd like to pass it off. Dom, thank you all for coming. Let's start it off.
Thank you very much, Mike. I first would like to thank the teams from Keycode Media and StorageDNA for putting this event together. Thank you so much on behalf of Sony. Sorry, I hit the wrong button there. Getting used to it here. So first, I wanted to give you a quick introduction to Optical Disc Archive. The first thing is, as far as the technology benefits and overview, Optical Disc Archive is Blu-ray technology based on XD-CAM. So what we've done is we've taken those single disc of XD-CAM, the Blu-ray disc, and put them inside a cartridge. There's 12 discs that can fit inside a cartridge. And we span them as one volume. So currently, the largest capacity that we offer is 1.5 terabytes. We have an open file system. That's essentially how you arrange data on a optical storage. And we follow the universal disk format for that open file system. The other key advantage of the technology is its random access nature. So random access to disk. And we'll highlight that throughout this conversation today. And generational backward compatibility. When you consider disk and you consider LTO, there's migration that's needed through those two different technologies. On average, and customer mileage may vary, with disk, it's 3 to 4 years that you need to migrate your to a new disk system. On LTO, the generational roadmap stipulates every 2 generations you have to migrate. So you're forced to migrate. There's costs associated with that. There's pain points associated with that. With Sony's Optical Disc Archive, as we introduce future generations, we are maintaining that downward read compatibility to the previous generations. So again, as we introduce generation 3 and beyond, we will be downward compatible to all the way to generation 1. Wanted to talk about some of the models that we have, capacities that we offer currently in generation 1. We have capacities of 300 gigabyte, 600 gigabyte, 1.2 terabyte, as well as 1.5 terabyte. There's different types of media, from worm media, so you write once, read many, or rewritable media. The largest rewritable media we offer is 1.2 terabyte. The largest worm media we offer is 1.5 terabyte. One of the key advantages of Optical Disc Archive, when you compare it to LTO, for example, is the read cycles. We can read an ODA cartridge more than 1 million times. LTO has disadvantages in respect to the number of passes before that media starts degrading. Again, 1 million read cycles with ODA. Significant advantage in the technology. Storage temperatures and operating temperatures. We achieved 50-year archival life from doing an accelerated test through the Arrhenius law. It's an ISO standard, and we achieved 50 years with temperatures of 104 degrees Fahrenheit and 85% relative humidity. Those same conditions, we tested LTO5. Under those same conditions, that media, LTO5, only lasted 5 years compared to, again, the 50-year that we did through the accelerated test. So the thresholds, the media resiliency is much greater with ODA, both on the low end with cold temperatures and on the high end with heat. So imagine putting a cartridge or an LTO tape in direct sunlight when you're on set. Imagine putting LTO on a server. Imagine a power outage. All of these factors are normal practices that can happen and start degrading media. ODA is much better positioned in that respect. We did another test, and you see a visual of it on the top left of the screen, where we submerged optical disc archive cartridges in salt water. And we did it for a period of time. It's about 5 days. We put a staple in the cartridge. After that 5-day period, we took out the cartridges, we took out the disc, and we rinsed them off and put them in a new cartridge. And we were able to read that cartridge back again. All those media, all the discs in the cartridge, we were able to read them again. Consider Sandy, consider floods, consider sprinklers. Again, this media is positioned to be disaster tolerant. It's a true archival format in that respect. This is a comparison of storage options that are available. And on the left side, we have your NAS and SAN, and of course, these are your online editorial collaboration. This is where you have probably more costly. You have a number of concurrent users accessing the storage. And of course, it's more costly and needs redundancy. And then on the right, if you consider nearline type archive, deep archive solutions, LTO has limitations in respect to frequent migrations that I stated, in terms of accessing that content, and in terms of the shorter data retention. It's 30 years compared to 50. The way ODA is positioned, it's really a combination of tiers. It's positioned as a nearline and deep archive, or a true archive in that respect. So it's a combined tier of nearline and archive. This is a YouTube video that we have available. Feel free to take down the YouTube URL, and you will find that this compares LTO 6 to our current generation 1 of ODA. And in this video, you will see the benefits of restoring, for example, a 1 gig file compared to an LTO 6. And in just this graphic here, you can see 3 seconds compared to 1 minute and 31 seconds to grab a 1 gig file. When we talk about random access, that's what we're talking about. That's some of the benefits you get in getting to that data quicker. You guys may have heard Archival Disc. It's a format that's been jointly collaborated with Panasonic and Sony. We're talking about the bare disk inside those cartridges that I referred to earlier. It's a 12 individual disk. The next Archival Disc is the next generation of Blu-ray. And in that technology, we're going to have 300 gigabytes available in the Archival Disc format, which we're going to call Gen 2. There's an Archival Disc white paper that's available. This was just released. This is a joint effort from Sony and Panasonic. Please feel free to go on the web, and you will be able to find this published Archival Disc white paper. It has information about cold storage, about physical and logical formats, a lot of technical specifications of Archival Disc. Now, Sony's implementation of Archival Disc with our optical disc archive, we're currently as generation 1, as I mentioned earlier, Our next generation is going to be generation 2. We're looking to achieve over 3 terabytes generation 2. That's going to be available for shipment around late spring of 2016. So we're basically taking those 300 gigabyte disks times 12, and we're going to get over 3 terabytes. That's the goal. And then we have generation 3. I mentioned downward compatibility, no forced migration. Again, that generation 3 is going to be able to read generation 2 and generation 1. In generation 2, the way we're achieving the double performance and also increased capacity is outlined there in the diagrams on the right. As you see in the top right, we're implementing the bits on the land and groove. We're also doing a narrow track pitch. We're maintaining the laser specification so that there's that downward compatibility that I mentioned. We're also increasing the number of heads. We're currently at 4 laser heads. We're increasing it to 8 in Gen 2. So these are the ways that we're increasing both the performance and larger capacity. So what solutions in terms of hardware does Sony offer for ODA? So we currently have here on the left, we have a standalone drive, and that is based on USB interface. So you can go to our website, download the drivers, you can work with Windows, Mac, and Linux. And then on the right is an enterprise class storage system. You start off with a master unit, which is 30 slots, 2 drives. You can add some extension units. Extension units come in 2 different options. One is available with capacity slots of 101 capacity slots. So if you were looking just to increase your storage capacity, you would just add one of those storage capacity slot extension units to the main unit. If you wanted to increase performance and capacity, you would add what we call our 60E, and it offers you 4 drive slots and 61 capacity slots. So if you were to scale all the way up, you can get 535 slots. So with generation 1, it's just below 1 petabyte. With generation 2, it's just below 2 petabytes. And what we're showing there, you could basically communicate to multiple libraries. The nice thing about StorageDNA's solution is in a single standalone environment, you could also work with the enterprise environment. So what I mean by that is, if you were in your enterprise environment, you had a cartridge in there, you exported it, you basically can insert that into a standalone environment and be able to access that content. Not all middleware companies do that. It's a very nice feature with StorageDNA. I wanted to give you a quick overview of just the 40 worldwide partners that have integrated and certified Sony Optical Disc Archive. StorageDNA has brought the integration of Optical Disc Archive to new levels. Being able to directly access an ODA cartridge. And TC will be able to expand on that in this next session. Thank you very much for your time. Thank you for being here.
Guys, I want to thank both Sony and Keycode Media for having StorageDNA present today. I'm going to kind of pick up where Dom left off, which is StorageDNA's integration with Optical Disc Archive. StorageDNA is a software middleware company with predominantly known for our integration with LTO and LTFS. And what we wanted to talk about is give you a quick preview of what we've done with the Sony Optical Disc Archive technology. This is a slide I always put up because I believe everybody is facing this. We're getting a lot of content. HD is left far behind. We've just been dealing with 3D. Now it's 4K, Ultra HD, high frame rates. Whichever format we talk about, it's a lot of content coming our way. And one of the key questions that everybody asks is, where am I going to put all this content, right? All this file-based media that's coming our way, where do we put it? And if you kind of stand back and evaluate the options we have available today, one of the first ones that jumps out is removable hard drives. Now, removable hard drives is one of those things which is low cost, it's easy, but we all know that it's not the most preferred way to store your file-based content long-term because it's not very reliable. But because it's easy, a lot of people still resort to hard drives. You buy a bunch of GTEC RAIDs, and you put your content on it. And it's a practice that a lot of people are still guilty of doing. And it's because it's easy, right? So, however, what people have realized that they need something more robust to put their content on, and that's where people fall back to LTO today. And LTO is low cost, it's reliable, but it's got an IT operational barrier sitting in the middle. And it's serial access, which means that anytime you want to get access to your content sitting on LTO tape, you got to restore it back before you can use it. And however, because of the low cost and reliability factors, LTO is quickly becoming the de facto storage medium where pretty much all content is flowing to and residing. But one of the big issues that happens with LTO is that because end users cannot get access to that content, a lot of the content that end users want access to remains on your nearline or your online storage. So the reason I put up nearline storage in a long-term archival section is because that's what's happening by default, because end users want access to their content. When it goes off to LTO, they lose access to it, so they prefer to keep all this content online or on nearline storage. And nearline storage is a lot more expensive, right? And it's not really a true archive. I mean, I can't pick out a hard drive from a RAID or from an object storage system and hand it over to somebody and say, hey, this is good for 50 years. I mean, you can't even read the data off of that drive, right? So it's not exchangeable. It's not long-term. It's on a proprietary format. But people continue to put long-term data on nearline and online storage systems because it's convenient, right? So one of the issues that we are seeing in the market today is it's either sitting on online and nearline storage, which means you're going to have to spend more and more to scale that, or you're putting it off to LTO. But the second you put it off to LTO, your end users scream that they don't have access to their content, right? So we've always been looking for a middle ground, right? And that's kind of where we got very interested in the optical disk archive technology. Well, I mean, Dom's kind of stressed upon this already, but you pop one open and it's 12 Blu-ray discs. And the most interesting part about it is this to us, random access, right? So when we looked at optical disk archive, we said, we've got hard drives and spinning disks for random access, and that's why we like them. And that's why we like LTO. But, Sony Optical Disc could be both, right? Which presents now a new and a very interesting option to store all this content that's coming in, something that you can put your data on long-term, but something that's also palatable for an end user to put into a drive and use right away because it has random access on it, right? So that's the reason why StorageDNA got very, very attracted to Sony's optical disk archive technology. So what did we do next? Well, we started developing software to integrate to Sony optical disk archive. So StorageDNA, we've traditionally been in the LTO, LTFS integration space. And we have over 500 LTO, LTFS deployments. And we probably have the most amount of experience dealing with LTO tape and dealing with LTFS. So we already knew all the different workflows and all the different ways the media industry was using LTO and LTFS. So we knew exactly what we wanted to do with ODA when we did integrate to it. And when we did integrate to it, our focus was to create a technology that enabled us to maximize the random access capabilities of this medium and to be able to make it end user friendly. So we wanted to be such that an end user could take a piece of content sitting on an optical disk archive, put it into a drive, mount it, and just directly use it in Avid or directly use it in Final Cut, right? And that was the reason why it took a while for us to get this integration out. Well, one of the first things that we hit is something interesting that comes out of the fact that if you look inside an optical disk cartridge, it's got 12 Blu-ray discs on it, right? Each one of these discs is randomly, provides random access. But the question is, if I have files that are striped across these disks, and I decide to expose this entire cartridge off to an Avid, I'm going to start getting disk load times and switch times, which means that from the application or the end user's perspective, it's going to hang. So one of the first things we had to combat and figure out is how do we make a medium that has multiple layers of disks in it work in a way so that an end user can find the interaction meaningful, right? So you'll see we'll talk about the first technology that we dealt with was something called smart access. Okay, and that's the key differentiator of all the integrations done with Sony Optical Disc Archive by the 40 other vendors, and what we do differently is we enable you to directly access content from the ODA. So how do we do it? And this is a quick summarization. So let's take an example where we have 10 files, and different files are striped across different disks in a cartridge. What we do is we track which files are written to which disk as we are storing the data on the optical disk cartridge. And this is thanks to some customized API work we did with Sony. Now, when an application or an end user requests access to those files, we mount the cartridge, but we only expose one disk worth at a time. And as the application of the user is done using each disk, we load the next one in and the next one. What I want you to think about is the same workflow that you might have when you had 10 XD-CAM disks, and you put one and you would use it, you eject it, put the other one, and you would use it again, except that's all happening automatically and through a virtual button rather than you physically having to load the media, right? A lot of this will become clear when I actually give you guys the demo. And that's really what Smart Access does. Smart Access makes it possible to use ODA as a random access medium in post-production and production workflows. And this is kind of just a quick example to show you that on the default Sony Optical disk behavior, we get random access to one disk at a time. But the issue is of switch times between disks, whereas StorageDNA can handle all 12 disks and an experience that is, as I said, palatable across multiple disks. So what can you do with Smart Access? Well, pretty much everything you can do with a hard drive. So with Smart Access mounting an ODA cartridge, I can directly access files off of the ODA. I can browse it, I can play it, I can ingest, I can edit, I can transcode, I can conform, I can subclip, which in the world of archive is considered and known as partial restore. So we're now talking about a piece of media that you can store on a shelf for 50 years, but you can mount it and use it like a hard drive, right? And which is a very interesting proposition that we believe for the entire industry. So what does the architecture look like? Well, so what we implemented is we said, hey, let's start off with the standalone drive or the library system. And what we did is we basically said we'll put network servers in front of it. And what we've put is also a little bit of disk cache. And why do we put the disk cache? Well, we put the disk cache there because if you're trying to archive data to ODA, remember ODA is a single write medium. Only one person can be writing data to at any point in time. And what the disk cache does is multiple people can be dragging files over the network onto the server, and it serializes the write to the ODA. So that's one of the reasons why we put it there. And we made the system network accessible, so anybody on the network can drag files and archive. As you archive files to the disk, it is behind the scenes transported off to the ODA medium and the ODA cartridge. Now, you can do a traditional restore as well, which is what most people do from an LTO medium, but the key is the ability to directly mount and use the cartridge like a hard drive as well, right over the network, right? So that's the interesting bit we've done. What I'm gonna do is I'm gonna switch over to that that iMac over there, and that iMac's running Avid. And it's sitting on a network and has no specialized software installed on it. And what I'm going to do is I'm going to mount an ODA cartridge, which is sitting on the library system right behind this wall. And I'm going to mount that cartridge. I'm going to open up Media Composer, and I'm going to directly AMA link some media off of the ODA cartridge. I'll link some red 4K footage off of the ODA cartridge, and I'm going to transcode it. I'm going to subclip it, and do all the things we are used to doing off of a hard drive. And the demonstration here is that if your media is in an ODA cartridge, I can actually do all the things I can do from a hard drive directly off of that piece of media, right? So that's something interesting we want to show you guys. So I'm going to walk over here and do that. Let's minimize this. So the first thing I'm going to do is log into our web interface. Okay, and this is the management console. And if I click on this archive, you'll see that I've got a whole bunch of data that I've archived, and it's sitting on this ODA cartridge right here. Okay. Now what I'd like to do is, normally I would select all this data, and I would say, hey, I'd like to restore it back, which is a traditional mechanism in how an LTO system would work. But instead, I'm going to say, I don't want to restore it, I'm going to smart access it. And what smart access ends up doing is it ends up queuing all the files that I want to actually directly use off of the ODA cartridge. I'm going to click Start. And what that's going to do is tell the system to now load the cartridge and link the files in rather than restore it. I'm also going to, in parallel, move over here. And if you see, there's a share already mounted here called SDNA mounted cartridges. And this is really where any cartridges that I mount over the network are going to appear. So as you'll see, it's already loading the cartridge over here. And this means that it's actually telling the robotic system to pull the cartridge from a slot into a drive and load that for you. But instead of loading it and restoring it, you're going to end up loading it and directly accessing it. So you're going to have to pay the time for actually have the robot pick it up. But what's going to happen is once I flip over to mounted cartridges, you'll see this cartridge appear 000A2 over here. So let's give it a few seconds for it to load. All right, so you see that the cartridge has appeared, and the file should appear shortly. And what the system is doing right now is essentially linking the files in rather than restoring it. Now, if you looked at the amount of data I'm accessing about 36 gigs of data, which has come back to me in about 30 seconds, which would be an 8-minute or a 10-minute restore off of LTO. Now, the files you guys are seeing appearing, including these red files, have not been restored. They're just linking directly off the ODA media. Okay? So now to prove to you that I can do a whole bunch of things off of this, I'm going to take the worst case scenario. I'm going to go into Avid Media Composer. Okay, I'm going to create a new bin right here. And I'm going to AMA link this red media. And you can see it's off the ODA network share. I'm going to AMA link this red media directly off the ODA. Okay. I hit that icon when it appears. Give it a few seconds. All right. So what we have now is AMA media that's red code, raw, that's linked essentially directly off the ODA. So let's play it. Now this is media playing off the ODA over the network, right? And I haven't restored anything. I'm using it directly off the media. Now I can do things like, hey, let's do a mark-in. Let's do a mark-out directly off the ODA. I'm going to create a subclip, okay? And then I'm going to transcode it to DNX36. Convert. It's complaining that I don't have the right the right resolution. But what I want to demonstrate to you guys is I'm working with 4K media. I'm subclipping 4K media directly off this medium now. I mean, it's pretty much functioning like my nearline storage, right? And we let that complete. But the idea here now is that you're now dealing with a piece of media that can go on a shelf for 50 years, an end user can mount it, you can subclip it, you can conform from it, pretty much all the things you did from your nearline storage. Okay, and you see it's pretty fast. It's transcoding right over the network, right from the ODA cartridge. Okay, and that was just a quick demo I wanted to give everybody to show you guys the power of what ODA can do. Okay, let's go back to slideshow. So just for some concluding thoughts, right? We all know the data monster is coming, right? And the key question is, what are we going to do with this content that's coming in? And today, all of us have an option, which is between access and cost. Either keep this stuff on nearline storage, keep it on object storage, keep it on my NAS, keep it on my primary storage, and I have access to it. But when I put it on LTO, yes, I've saved on space, I've saved on cost, but I've given up access. Now, what ODA does with StorageDNA software integrated on top of it is gives you a third option, which is, what about both? You get cost, because it's way, way lower cost than keeping your media online on your nearline storage or on your primary storage. You get access, and it's long-term, and it also serves as a long-term media. So that's something I think is a new option that we are very excited about, and we wanted to show you guys a quick preview of that today. Just want to thank all you guys for being here. If you have any questions or we want to see a demo, we're right behind that wall back there. So thank you guys.